This video is for educational purposes only. Do not attempt this without proper safety precautions and supervision. Exceedingly high temperatures can burn skin and flesh before it can react, so please be responsible.
Yeah, guess who's here? It's me. I don't have a script for this episode, but it's mostly because I had to throw out my script since it didn't work. This is my failed forge, now kiln. Initially, I wanted this guy to melt copper, but I knew that wasn't going to happen. And can it? Yeah, I can. But still will be pretty interesting to see how hot it does get. Let's start with the design. It was based off old medieval kilns so that I could hopefully get up to temperature once I force fed it air. Our design started with this blocky and unfinished roof look. I didn't really like it, so when we decided to move on to a curved roof, I didn't exactly know how I was going to get the faceplate. We initially thought that these little bars on the sides would hold it together while the inner rebar kept it together, but we eventually decided that casting the faceplate would be the best option in order to properly support the top. For my initial base, I decided to take apart a weather mill in order to collect the metal, which I would make into a grill to sit the forge on. I cut this metal into the base, and then drilled and bolted it to a wood frame. Next, I worked on the bricks. The ratio was 6 parts perlite to 1 part clay, 1 part ash, and 2 parts cement powder. Once the bricks were done drying, I sanded them down and stacked them up in a box. I then placed the bricks on top of a solid plate, the construction of which was poor, to say the least, with clearly defined layers, a defect that will be important later. I then had to attach the grill onto the table. This warranted a quick trip to my local Home Depot to pick up some not garbage strips.
You're good, dude. Nice. Let's go.
I also decided to get materials for a different project. When I got home, it was straight to attaching the grill to the stand. Then
Alright.
placing the bottom slab on top and assembling the
It
frame.
is time.
I drilled holes through the bricks to support the wire reinforcement.
I think I'm forgetting something. Oh yeah, the mortar.
For the mortar, I used simple clay extracted from dirt, then began stacking the bricks. I'm hoping that because I am using fragile mud as a mortar, if a brick were to fail, then it would be easily replaceable. Then I began on the arch. Although I should have used an interlace pattern, I instead decided to go straight up because it would have been easier to manufacture.
Here it is. The side. The back, which I need to fill in with bricks. And the top. It makes a nice sound though. And ready for this horrible part? It's wacky back here. This is actually, it actually caved in when I was doing it because this twine here wasn't tight enough.
Once the arches were finished, I temporarily blocked up the back for the very first test.
Did it already die?
No, it's not. It just disconnects for no reason. Ooga booga. You want to be the cameraman?
I mean, I can't. Just kind of falling.
You want to throw it in? Just smack the side. Just, yeah.
It's fine.
It's fine.
From the test, I was able to determine that the reason the fire was not getting hot was a lack of airflow, partially caused by the small airspace below getting filled. My solution was to break apart an old flagstone to build a new base, one with enough space so that it would not get clogged with ash.
I ran out.
I sealed it up with the same method as I did with the forge. Then I tried to place the forge on top of the new base. This went as well as you might have planned, and I broke it.
Oh, okay.
When we finally got there, this was the damage. For the faceplate, I used chicken wire as a support and broken or defective bricks as the filler. When the faceplate was done drying, I inserted it into the front of the forge. Then cast the new door with handles and installed it into the faceplate. With the back now properly sealed, all that was left to do is add the exhaust hole on the top. The following tests, although promising, had proven some of my suspicions correct. For one, the forge was still getting clogged with ash because the holes I drilled into the base were still too small. This is especially apparent later on in the tests. And, on top of that, the faceplate didn't provide enough room to clean or properly access the fire. In the end, I was forced to cut open the faceplate to make a better opening. On top of that, I drilled a larger square hole in the back after being taught about how airflow works back in college. The final test was incredibly promising. The kiln was able to get the stainless steel crucible to a glowing yellow.
Hold up.
However, this was only on the top, the hottest part of the kiln.
You can hear it boiling.
To put this test to good use, I decided to use the calcium carbonate from the heat test to make some lye.
This is the end of the video.